I have a chair here. It has 4 legs, obviously. 2 are orange and the other 2 are black. I also have an uneven ground here which goes up and goes down. The problem is the chair is perfectly alright, but since the ground is uneven, the chair wobbles. Now how do I fix that? Of course I can take the chair out and place it on an even ground, but that's not what I want. I want to fix the chair on the uneven surface. How do I do that? Well, math comes to my rescue. Before we fix the chair, let's learn about continuity. Clearly the maker of the video doesn't know what continuity is. So what does continuity mean? Well, if you have a mathematical function and if it is continuous from say this point to this point, it means that you should be able to sketch the function without lifting your pen. Maybe the function looks something like this. So this function here is continuous over this interval. That makes sense. Now what does it have to do with our chair? Well, there's a theorem called the intermediate value theorem which applies for such continuous functions. What that says is, if the value of a function is negative at some point and if it is positive at another point, then the theorem says that the function has to be 0 somewhere in between if it is continuous. That makes sense because if you try to draw any curve that goes through this point and this point without lifting your pen, you will have to cross the 0 point somewhere, right? So if it is negative at a point and positive at another point, it is 0 in between. That's what the intermediate value theorem says. Now, this much knowledge should be sufficient to solve our chair problem. An interesting observation to make here is that currently the black legs are stable and the orange legs are wobbly, right? Now if I rotate the chair by 90 degrees, the orange legs are stable and the black legs are wobbly. I've defined a function y is equal to black minus orange. Here black is the total height of the black legs above the ground and orange is the total height of the orange legs above the ground. Initially the black legs are stable and the orange legs are above the ground and hence the function is negative. After rotating the chair by 90 degrees, the orange legs are stable and the black legs are above the ground and hence the function is positive. What the intermediate value theorem says is that somewhere in between the function has to be 0. In other words, the chair is stable. Let's try that out. So the wobbly chair here can be apparently fixed by rotating it. So let's try that out. A little rotation and boom, the chair is stable. It's not wobbling anymore. What we have just learned here is called the wobbly table theorem. Seriously, not even making that up.